Hello students, I am Dr. Brajabandhunanda. This is my lecture 2. Today I shall teach you the methods of preparations of alcohols. All of you know that there are different methods which are used for the preparation of alcohols. The first method by the hydrolysis of haloalkanes. Alcohols can be prepared by the hydrolysis of haloalkanes with aqueous KOH solution. Here Rx is the alcohol is alkyl halide plus aqueous KOH. It will give rise to KOH plus KX. If we are taking ethyl bromide which will be treated with the aqueous KOH, then it will give rise to ethyl alcohol plus KBr. The bromine of ethyl bromide will be replaced by the K plus ion of OH minus ion of KOH to give C2H5OH or CH3CH2OH. Alcohol can also be prepared by reacting the alkyl halides with moist silver oxide. If we are taking ethyl bromide in presence of a moist silver oxide, then CH3CH2Br plus AgOH converted to CH3CH2OH and AgBr will be produced. Alcohol can also be prepared from carbonyl compounds. Carbonyl compounds are aldehydes and ketones which contain C double bond O group. Alcohols can be prepared by the following methods. First method is by the reduction of carbonyl compounds. The reduction can also be carried out either H2 in presence of a nickel or platinum catalyst, or with lithium aluminum hydride or sodium borohydride dissolved in anhydrous ether. Reduction of carbonyl compounds by sodium and alcohol is called bubbled blank reduction. Aldehydes upon reduction form primary alcohols. You see RCHO in presence of H2 in nickel or platinum catalyst, or in presence of a lithium aluminum hydride, or in presence of sodium borohydride, the CHO group will be converted to CH2OH group. That means it is converted to primary alcohol. So in case of ethanol, it is converted to ethanol in the same reducing agent. Ketones upon reduction form secondary alcohol. You see RC double bond OR in presence of H2, then it will converted to RCHOHR. That means the carbon will contain one H, the oxygen will contain one H. So CHOH. So it is a secondary alcohol. CH3COCH3, this is the acetone or propanone. When reduced under same condition, it will give CH3CHOH CH3 propan 2-ol or isopropyl alcohol. It may be noted that sodium borohydride does not reduce a carbon-carbon double bond in a conjugation with a carbonyl group, while both lithium aluminum hydride and a catalytic hydrogenation causes their reduction. For example, I am just giving you a but-2-enol. This is called crotonaldehyde. When treated with sodium borohydride, it will give you but-2-en1-ol. Here the double bond is not reduced. Let us give the mechanism of the reduction of carbonyl compounds. So first the lithium aluminum hydride will converted to lithium ion plus aluminum hydride ion. The aluminum hydride ion will lose one hydride ion, and that hydride ion will go to the carbon atom of the carbonyl compound, because the carbon atom of a carbonyl compound contain delta positive charge and oxygen contain delta negative charge. So it will converted to RCRHOALH3. So that again react with 3 moles of ketone or carbonyl compound to give RCRHO whole 4 Al minus. So it will lose 3 water molecules to when reacted with 3 water molecules, it will give 4 RCRHOH LOH thrice. So this is a secondary alcohol that ketone will give. So again, we can prepare alcohols by the action of a Grignard reagent on carbonyl compounds. Aldehydes and ketones on reaction with the Grignard reagents are MgX in presence of an anhydrous ether give immediate product which on hydrolysis in presence of inorganic acid gives alcohols. I am just showing you. C double bond O, this is a carbonyl compound when react with RMgX. You know that here R is negative, MgX is positive, and a C double bond O, C is delta positive and O is delta negative. So R of alkyl magnesium halide will it go towards carbon atom, and a MgX of alkyl magnesium halide will go to oxygen, which is given as the right hand side product, that is called addition product. And that addition intermediate on acid hydrolysis will give COHR and MgXOH. This is alcohol and this is hydroxy magnesium halide. Formaldehyde gives primary alcohol because HHC double bond O, one CH3 group will come, methyl magnesium bromide is here, iodide. So one CH3 will come to carbon, so it will gives addition product as given here, and water is added and H will come to O and OH will go to MgI as a result of the formation ethyl alcohol CHH OH CH3. So CH3 CH2OH. This is ethyl alcohol plus MgOHI, basic magnesium iodide. Other aldehyde gives secondary alcohol. Instead of taking this formaldehyde, if you take acetaldehyde, then what will happen? You see CH3C double bond OH. So another CH3 from methyl magnesium iodide will come to this carbon. As a result of the addition product will be CH3C CH3H OMgI. So when water will be treated with it, then H will come to O and OH will come to MgI. Then the product will be isopropyl alcohol plus MgOHI. Similarly, benzaldehyde when treated with methyl magnesium iodide, then the alpha phenyl ethyl alcohol is formed, which is also a secondary alcohol. Ketone when treated with methyl magnesium iodide or Grignard reagent, it gives a tertiary alcohol as follows: CH3CH3 C double bond O plus CH3 MgI when gives rise to CH3CH3C OMgI CH3. You see there are 3 methyl groups present around the carbon atom. So OMgI is here. So in out of when water dissociates HOH, then H will go to oxygen atom to form OH and OH will go to MgI, it will gives MgOHI. So it is a tertiary butyl alcohol. And another method of preparation by the action of alkyl lithium or carbonyl on carbonyl compounds. Alkyl lithiums react with carbonyl compounds in the same way as Grignard's reagent and form alcohols. You see C double bond O plus RLi converted to COLI and R. So in case of acidic hydrolysis, it will gives the OLi will converted to OH and the Li will go in the form of LiOH. Similarly, if an aldehyde will react with C2H5Li, so ethyl lithium, then what happens? It will first give the OLI complex addition compound, then OLI will hydrolysis gives OH and LiOH. This is a secondary butyl alcohol. Ketone also give a tertiary butyl alcohol as follows: acetone CH3CH3 C double bond O plus CH3Li converted to CH3CH3 COLI single bond CH3, and on hydrolysis it will give tertiary butyl alcohol. So preparation from carboxylic acid. Acids are directly reduced to primary alcohols with the help of a lithium aluminum hydride, which is a very strong reducing agent. Alcohol is formed in very good yield. Now I am just giving RC double bond OH, lithium aluminum hydride. So hydrogen will come from lithium aluminum hydride, and that will react to form RCH and OH, single bond OH. So that OH will again converted to the CH2OH. So it will give alcohol RC double bond OH will converted to RCH2OH plus water. I am just giving you acetic acid in presence of a lithium aluminum hydride. It will converted to CH3 CH2OH. That means C double bond O group will converted to CH2 group, and the oxygen atom will be removed to give water. From esters, alcohol can also be prepared as follows. By the reduction of esters, esters can be reduced in the same way as aldehydes and ketones by either catalytic hydrogenation or by complex metal hydride formation. RC double bond OR in presence of H2 and a nickel catalyst or lithium aluminum hydride or lithium borohydride, the C double bond O group will converted to CH2 group, and OR group will converted to OH group. Let us see, and what is the product at the right side? RCH2OH plus ROH. Now come to one example, ethyl acetate CH3C double bond O C2H5. When it undergoes reduction, then it will convert it to CH3CH2OH and a C2H5OH. So both are ethyl alcohol, so it will give 2 moles of ethanol or ethyl alcohol. By the action of Grignard reagents, so esters combine with Grignard reagents in the same manner as aldehydes and ketones. However, 2 moles of the reagent are used, one to convert ester into carbonyl compound and the other to convert carbonyl compound to alcohol. Let us prepare step by step. Okay, here ethyl acetate is taken CH3C double bond O OC2H5. When it will reacted with the methyl magnesium iodide, the methyl group will go to carbon and O will attach with the MgI. Then what will happen? Then it will be C2H5O CH3 OMgI CH3. So this is the addition product, and when it undergo acid hydrolysis, when it releases C2H5OMgI, then what happened? It will give acetone CH3CH3C double bond O. This acetone again react with the methyl magnesium iodide. So just like previous what I have discussed, it will give CH3CH3C OMgI and a CH3, and it will undergo acid hydrolysis to give CH3CH3COH CH3. This is tertiary butyl alcohol and a basic magnesium iodide. Ester of formic acid will form secondary alcohol on reacting with Grignard reagent. By the alkaline hydrolysis of ester, which is also known as saponification. Ester, when treated with aqueous alkali, aqueous NaOH or KOH, it is converted into sodium salt of acids and alcohol. This reaction is known as saponification reaction. So RC double bond OOH plus NaOH gives rise to RC double bond ONA plus ROH. That means the OR group will be removed by OH. Yes sir, ONA and the OR and H, it will give ROH. Now ethyl acetate when react with NaOH, it will give sodium acetate plus ethyl alcohol. And a preparation of alcohol from aliphatic primary amines. Primary aliphatic amines when treated with nitrous acid, actually nitrous acid cannot be available in the laboratory directly, and it will be available by reacting NaNO2 plus dilute HCl. And when this compound reacts with aliphatic amine, it gives primary alcohol. Let us see. RNH2 plus HONO. It will, HONO means nitrous acid. It will give rise to ROH plus N2 plus OH. And a C2H5NH2, this is the ethylamine, and a HONO is the nitrous acid. It will give rise to C2H5OH plus N2 plus H2O. Then if you take benzylamine, it will give benzyl alcohols. And how can we prepare alcohol in industrial method? Alcohols can be prepared on commercial scale by following methods. First is the preparation from alkenes. By the hydration of alkenes or addition of water. Alkenes on reaction with sulfuric acid at room temperature to form alkyl hydrogen sulfate, which is decomposed by water on heating to form alcohol. You see here, alkene is taken on the left hand side plus H2SO4. H2SO4 means HOSO3H. The one H will come to one carbon and OSO3H will go to another carbon. Which in hydrolysis? So OSO3H will be removed by OH. So it will be alcohol, and H will go to OSO3H. So sulfuric acid is again regenerated. That means ethylene when react with sulfuric acid, it gives ethyl alcohol. When propylene will react with sulfuric acid, it will give propan-2-ol. It is a process of Markovnikov's rule, because the negative part will go to the carbon containing less number of hydrogen. We shall see the mechanism how it is produced. RCH double bond CH2. This is alkene. When it is react with the H plus, where the H plus comes? H plus comes from the dissociation of H2SO4. And this H plus either will go to the last carbon or go to the middle carbon. If it will go to the last carbon of the double bond, then the secondary carbocation is formed. It will go to the middle carbon, then primary carbocation will be obtained. You know that the secondary carbocation is more stable than the primary carbocation. Therefore, this is produced. And one water molecule will come, and you know that the lone pair electron present on oxygen will come to attach with the CH plus of the carbocation to form a molecule, to form a complex like this. So this is an unstable compound and loses one H plus ion to give RCHOH CH3. So this is alcohol. By the oxymercuration, demercuration of alkene. Alkene reacts with an aqueous solution of a mercuric acetate in the presence of a tetrahydrofuran to form an addition compound, and the reaction is called oxymercuration. The compound is reduced by sodium borohydride in the basic medium to form an alcohol. The reaction is known as demercuration. You see the reaction. So alkene is taken on the left hand side in the presence of water and a mercuric acetate. It will give rise to COH single bond C Hg COO CH3. So this process, with the addition of a mercury to the double bonded carbon, is and forming the single bond is called the oxymercuration. Then we shall go for the thus the overall reaction involves the indirect hydration of alkene, but this hydration is faster than the acidic hydration of alkenes discussed earlier and require comparatively mild condition. For example, I am just giving you this is a butene. So in this butene, if we just add this mercuric acetate, then what will happen? The OH group will attach to the middle carbon and which contain less number of hydrogen, and HgOOCCH3 will added to the last carbon atom which contain more hydrogen. So when it will undergo basic hydrolysis, then it will the secondary butyl alcohol or butan-2-ol is produced. By hydroboration oxidation of alkene. Indirect hydration of alkenes can also be done by hydroboration oxidation, which is completed in two steps. In the first step, alkene reacts with diborane as boron hydride to form an alkyl borane. In fact, the boron atom along with the hydrogen gets attached to the double bonded carbon atom with more number of hydrogen atoms. One hydrogen is then transferred to the other carbon atom. In this manner, all the three hydrogen atoms of boron are transferred to alkene molecule to form trialkyl borane as the product. In the next step, the alkyl borane is oxidized by alkaline H2O2 to form an alcohol. The indirect hydration proceeds according to the anti-Markovnikov rule. I am just showing you CH3CH double bond CH2 plus BH3. If we take 3 moles of propene, then 3 atoms of hydrogen from BH3 will be added to the middle carbon atom, and it will form CH3 CH2 CH2 dash. So this radical is formed, and this CH3 CH2 CH2 radical will combine with boron to form tri N-propyl boron, which on basic hydrolysis gives 3 moles of CH3CH2 CH2OH plus H3BO3. So this is a primary alcohol. So propan-1-ol is produced along with boric acid. Hydration of alkene proceeds according to Markovnikov's rule except for the hydration with the hydroboration oxidation, which follows anti-Markovnikov's rule. By this process, a primary alcohol can be produced. But in the previous processes, what I have also given, so that was a Markovnikov's rule, so secondary alcohols will be produced. By OXO process. In this process, an alkene is treated with a mixture of a carbon monoxide and a hydrogen at high temperature and pressure in the presence of a OXO catalyst, which is octacarbonyl dicobalt CO2 CO holate, formed by passing carbon monoxide gas over cobalt metal. An aldehyde is formed which upon catalytic hydrogenation is reduced to a primary alcohol. I am just showing you the example. CH2 double bond CH2 plus CO plus H2. So in presence of octacarbonyl dicobalt, what will formed at high temperature and pressure? CH3 CH2 CHO will be produced. That means the CO plus H2, it will form a one H will go to first carbon CH3 and a single bond CH2 CHO. So that's a propanol is produced, which on reduction in presence of hydrogen and nickel catalyst, it will give rise to propan-1-ol. So that is the propanol is formed. So preparation of carbohydrates. Ethanol or ethyl alcohol can be prepared on commercial scale by the fermentation of a sugar present in the molasses and grapes, etc. The starch present in the rice, barley, maize, etc. The reactions that are taking place are catalyzed by certain enzymes, also called biocatalysts, and are present in yeast. It is interesting to note that the making of a wine, grapes are the source of both sugar and yeast, which brings about fermentation. When grapes are crushed, sugar and enzyme interact and the fermentation process starts. Fermentation takes place under anaerobic condition, that means in the absence of air. Carbon dioxide is evolved during the reaction with brisk effervescence. As a result, it seems as if the solution is boiling, but actually it is not. The chemical reaction involved in the process of fermentation as given below. You see, first we are taking sucrose C12H22O11 plus H2O. In presence of invertage, it will converted to glucose plus fructose. Both are having same molecular formula, but their functional groups are different. Glucose contain aldehyde functional group and fructose contain keto functional group. So again C6H12O6 in presence of zymase is converted to ethyl alcohol plus carbon dioxide. Fermentation of a starch. Instead of a sugar or grapes, the alcoholic fermentation can also be carried with barley, potatoes, corns, etc., which contain in them starch with general formula C6H10O5 whole N. Unlike sucrose, starch has no taste. Its fermentation proceeds as follows. So C6H10O5 whole N plus N water in presence of a diastase, it will converted to C12H22O11. This is called maltose. This maltose when react with water in presence of maltase, this is one enzyme, then it will give 2 moles of glucose. Then glucose when treated with zymase, then it will give ethyl alcohol plus carbon dioxide. So preparation of a methyl alcohol from water gas. Methyl alcohol or methanol can be prepared commercially from water gas. Water gas, you know that this is a mixture of a carbon monoxide plus hydrogen formed by passing steam over red hot coke. C plus H2O converted to CO plus H2. This is water gas. Water gas is mixed with half its volume of hydrogen and is passed over a catalyst mixture of oxide of zinc, copper and chromium under high pressure of about 200 atm and at 623 to 673 Kelvin when methanol is formed. You see CO plus H2, this is water gas, plus H2 excess in presence of a CO or zinc oxide or Cr2O3 at 200 atm and at the temperature of about 623 to 673 Kelvin, it will give methanol. This is a commercial method of preparation of methanol. Thank you.